Welcome back, guys. I wanted to make another video today with the FST cam marble. What we need to do also is I need to make you aware that there's always updates with this program, and if you go to the Sasso Mechanica website, you'll have an option for the Italian language or the English language. Once you choose which language is suitable for you, there's a pull down for support, and a sub menu on there is software, and you can find the latest downloads. Okay, here, please be advised, in our case we would have our date as October 27th 2014, and this is going to be 27 October, so be careful for that, okay? Alright, so what I want to talk about right now is making tools. This is a little bit difficult because we don't have a machine in front of me right now where I can demonstrate this, but however, tools, tool manager. Okay, so here's my first tool. This is number one. It's the disc. The code is 1. It's my first tool. The machine code is -1. This must be a -1. This is for the machine, letting it know what type of tool it has. A core bit or finger bit, anything like that will be a 1. But the disc, the blade, is going to be a -1. The description here could be whatever you want it to be. Okay, the direction is counterclockwise. Okay. Now, I'm going to start here with length 1, radius 1, not used. Length 2 is the thickness of the saw blade, 1/8. Now, when you buy a new saw blade, don't just take for granted that it is 1/8. Measure it with a caliper, or what I personally do is I actually cut into the stone a few inches, and I measure that opening, and I know that is going to be my blade thickness. Okay, so again, just cut into the stone, maybe a 1/4 inch deep, a couple inches long, measure that with a caliper. That's your blade thickness. Radius 2 is the diameter of the blade. Okay, so now you put a blade in the machine, you calibrate it, and it comes back and it says a number, 16.555 or whatever it is. You now have to take that number, divide it by 2, and put that in here. Okay, now, as the blade wears and it gets recalibrated, you need to update this value, okay? Now, you might be saying right away, oh my God, I just made 5 programs, and they were based on this radius, and now the operator says it's another radius. No big deal. All you have to do is change the radius, and then we have an automatic tool update, but you must compile again, okay? You must compile. Okay, so again, length 2 is the thickness of the blade, radius 2 is the diameter of the blade. Excuse me, it's the radius of the blade. Length 3. As you know, the blade is sandwiched, and there's a hub right here, okay? This is an illustration of the hub. That is the thickness of the hub. And again, that's never going to change. That's a constant. Radius 3 is the radius of the flange. And again, that's never going to change. So it's very simple here. The only thing you're ever changing is the width of the blade and the radius of the blade. Okay? The rotation, I've been using 1600, 1800 in that area, okay? Entry, exit, and work, all the same. Okay, the feed rate, again, in inches per minute. I put an entry speed of 7, an exit of 70. Well, it could be faster. It could be, much faster, obviously, for exit. And the work is 70. Now, again, I will get 70 inches a minute as long as the potentiometer at the machine is set to 100%. Now, of course, I could make this 150. And then I get 150 when the potentiometer is at 100%, but I can always slow it down, all right? And again, depends on the stone. Is it a hard stone or soft stone? So again, this is for a blade, all right? Now profile, basically you're going to want flat. Why did I have spherical in there? That'll be another video coming up soon, guys. But basically, you're going to want a flat profile. So again, code 1, just it's tool number 1. Machine code is always -1 for a blade. 1 for a core bit, finger bit, okay? Description is disc, or it could be, you know, my saw blade or from XYZ manufacturing, whatever you want to call it. Length 1, radius 1, not used. Length 2, thickness of the blade. Radius 2 is the radius of the blade. All right, after you calibrate it, take that diameter, divide by 2. Length 3, radius 3 is the flange, which never changes. All right, that's for a blade. Now I have here a core drill that I made. It's tool number 2. Machine code is 1. There's my description. It's counterclockwise. All right, now the radius is 620. Length 1, where does that come from? You are going to turn the A-axis 90 degrees. You're going to go to the working parameters. And on the very bottom, it's going to say tool type. It's going to say grindstone. That's what they call a blade. You're going to change that to tool. You're going to bring the core bit down till it touches the tabletop. Then you're going to calibrate it. On the screen, it's going to tell you the calibration length, whatever it is. In my case here, it says 5 inches. Yours might say 7.1, 7.2, whatever that calibration value is, you're putting that number in here. Very simple, very simple. That's all you have to do. All right, these speeds, again, check with the manufacturer of the tool for what they suggest. I have 1400 RPMs. I have a entry of 3 inches a minute, an exit of 3000, and a work of 6. You know, 6 might be a little fast. Okay, that's all you need for a core bit. Again, bring the tool down till it touches the tabletop, calibrate it, whatever that number says goes in length 1. Very easy. All right. I have a mill here, okay? Maybe it's a finger bit, something like that, all right? In my case, it's tool number 4. Machine code is 1. My description is a mill, counterclockwise. Okay. Where did this number come from, 6.625? All right. So I calibrated it. I brought it down. I touched the tabletop. And it came back with that number, 6.625. All right, now what you do, go right to length 2. Don't worry about length 1 just yet. You're going to put in, right here in red, that's the carbide, or the diamond, excuse me. That's your effective cutting area. In my case, that's 1.625. Take 1.625, subtract that from 6.625, that leaves you at 5 inches. So I put 5 inches in here. So length 1 equals the calibrated value minus length 2 becomes 5. So again, 5 plus 1.625, the sum of that is 6.625. Radius 1 is the radius of the shank up here, the shaft. And radius 2 is the red, my cutting area. That's the radius of that. I think it's usually 23 millimeters, those finger bits, which is 0.9 something. So again, that's where I got that. It's a flat profile. From my experience, it's like between 4,000 and 6,000 RPMs on those finger bits. Entry speed, I put 10. Exit, again, could be much faster. Okay? And working at 10 inches a minute. Okay, that's a mill. Again, where did these numbers come from? One more time. You calibrate it. In my case, it returned 6.625. Okay, my diamond, length of my diamond is 1.625. So I subtract the 1.625, it leaves me with 5. That goes into length 1. That's it. It is very easy. I hope you like this video. If you have any feedback for me, again, guys, I'm learning some of this as I go along as well. Please give me feedback at georgegerhardt@yahoo.com. Any questions, same thing. Hopefully I can answer them for you. But as I learn more about these machines, I'm enjoying it very much. It appears to be a well-built machine, does a good job. I'm enjoying posting these videos. I hope they help you. Good luck.